This path is nothing but the optimal path. This path is nothing but the optimal path. And always it is trying that particular so that it can find the minimum number of hops. It will reach to the destination with minimum hops. Why hops is the prime important here? Why hops is the prime important here? Anybody? I'll open the chat so that you can understand. Why this hop is important? Yes. As there is a TTL field, okay, this TTL is time to live, which decides the life of the packet and that sets the number of hop. Okay, so that count is 32, 64, 128, whatever may be. But always it is always it is there that within that particular stipulated number of hops, it should reach to the destination. Otherwise, packet get dropped. Otherwise, packet get dropped. Okay, so to reduce this dropping probability, it must take the hops into account. Okay. Again, what is, if at all I want that my packet should reach to the destination, what is basic routing? How it will give me guarantee that my packet will definitely reach to the destination? Hello? Lecture. काय बोल काय पाठवायचं हां हां मी करतो फोन. What is basic routing? What is the first method of basic routing? Already we have discussed. Forward to all. This is called as flooding. This is called as flooding. So if I use the flooding concept, that means multiple packets get generated from one packet and that will travel in the network, but that will create a lot of traffic. It is not at all recommended. So it will create unnecessary traffic because there are multiple paths to reach to the destination. And if I forward the packet to all paths, duplication of packet also takes place and it will create huge traffic in the network. That's why not recommended. But sometimes, if at all I'm completely unaware of this destination, this flooding can be used. Then if at all not flooding, another way is so that no much intelligence is required, because whenever we go for routing algorithms, there is some sort of intelligence required. Okay, that adds the complexity in the form, but without any complexity, the simplest method is flooding. The second method is selective flooding. Second method is selective flooding. Instead of sending it to the all, at least select the stations which are going in that direction or towards the destination, send the packets to them only. Otherwise, I want to send the packet to the east, for example, and I'm sending data to the west and north and everywhere also, this should not be the case. So in flooding, that is the major concern. But selective flooding, I can select number of stations, I can send that. Okay, but again, selective flooding is also not recommended. So point to point. How all these are possible? What is the first slide of IP datagram? How come all these are possible? Because very important is IP supports unicast, IP supports multicast, IP support broadcast. That's why these processes are very much possible. Okay, otherwise it is problem, because as it is supporting broadcast, I can forward it to all. As it is supporting multicast, I can use selective flooding. As it is supporting point to point, I can send up to the particular destination. Okay, that's why this is basically property of IT, which give property of IP, which gives me flexibility of multicasting, flexibility of broadcasting, flexibility of unicasting. Okay, that's why this becomes widely acceptable, popular. Before routing, there is a concept called as IP forwarding. Okay, before routing, there is a concept called as IP forwarding. Okay, so look at the figure. Look at the figure, how this IP datagram moves to the destination. Okay. So it will go to the router R3, then there are multiple paths passing that particular network going to the R4, or so it will select this path, then it will go to the R2, then it will reach to the destination. Okay. So internetwork is a connection of LANs, okay, point to point. Okay, that is switching takes place. And this IP, which is here, get forwarded, get it here, and then reaching to the destination. So all are point to point link. All are point to point link. Now what happens at the IP layer, because IP layer we have came across that it is using the logical addressing. It is using the logical addressing with subnet mask, and that is prime important, because that subnet mask will decide whether this particular packet is allowed in this particular network or not. Okay, with the changing mask, what we are achieving is subnetting and supernetting. Okay, in that scenario, this is very much important. Okay, so logical entity with network ID. So look here, it will go to the R3, then go to the R4, because what you can see here is 24 and here is 16, and what address here is 3 and here is 1 2. Okay, so as is the same, because of this 23, it will move here because net ID is this, and then it will move to the then it will move to the destination, because destination address is completely different. And what we can see in the second network is it is small network with /24. That's why the /24 /16 are prime important in terms of subnet concept. The following condition must be there so that it can successfully delivered. So network prefix must correspond to the unique DLL network, unique data link layer network. Okay, network prefix means net ID, what I am using. Okay, then router and host have common network prefix, and they can exchange the IP datagram. Okay, using data link layer protocol. either 802.3 or PPP or token ring or token bus, whatever data link protocols are there, which are typically MAC protocols, they must use this. So every DLL must connect it to at least one another DLL network via router. So here router is important because these are connection between the two LAN. Which is the another device can use to connect the two LANs? Which is another device can be connected to use the two LANs as different data link layer protocols are there. Means I want to connect the token bus with the conventional bus. I want to connect the token ring with the token bus. Then which device? Anybody? Instead of router, any other device which is working at data link layer can be used to connect the two LANs. Switch. Switch is point to point. Bridge, yes. Bridge is another device which are typically called as conventionally two different topologies can be connected using the bridge. Conventionally two different topologies can be connected using the bridge. But again, bridge working at DLL only. So it is typically used as a protocol converter. It is typically used as a protocol converter because when I change the topology, immediately protocol changes. When I change the topology, immediately protocol changes. Okay. Now how this routing takes place? How the router will come to know that on which particular destination port this packet need to be forwarded. Okay, because for the router there are 24 ports. On one port data is incoming. On which particular output port I need to forward or deliver this packet so that it will reach to the destination. For that, it is maintaining routing table. It is maintaining routing table. Okay, which is the use for finding out the outgoing path. Which is used for finding out the outgoing path. Because destination address where the IP datagram is going to, next hop that will give you how to send the IP datagram and interface at which particular port. At which particular port. Okay, because router comprises of 16 port, 32 port, 48 port, whatever may be the scenario. In that, every port is connected with a different interface and routing table will keep the track of that. Okay, keep the track of that. We'll see the example, then you can easily understand this, how these things are happening. And how the routing table gets created, what exactly the significance of this, okay, and how the table get updated. Because what we are discussing from the start is this network scenario is completely dynamic. It is not static scenario. That's why after every certain time it will get changed, because currently this machine is on. Okay, after finishing the lecture I will make this machine off. Whether the router will get this information that this machine is currently on with this IP in this MAC. After finishing the lecture, I'll make the machine off. So immediately router will come to know that now currently this machine is not in the network. How these things are happening. This is very interesting. This is very interesting. Otherwise, problem may occur. Okay, routing table are set to that datagram and get closer to its destination. So see the routing table entries. And here not the host address. Here what you can see is the network address. So this network address is very significant in terms of routing, because in this particular, now what you can understand is in the first network there are less machines because it is /24, so that machine count is 254. Okay, machine count is 254, whereas this network having the machine count more because it is /16, so that 254 in the last plus 254 in the previous. that many counts are there. So immediately you'll get the network information looking at the net ID. So IP datagram can directly deliver to the direct or send through the router R4. Okay, send to the router R4. That depends upon how the routing tables are maintained, how the destination path is set. Now you can see the figure, previous figure only. Now what you can see is it must send to the 20.2.1.2. So it will find that entry in the routing table. So it will forward that to the R3. Okay, it will forward that to the R3. Then again it will find that entry in the R4. So it will forward the packet to the R4. Okay. Then it will find the entry in the R2. And then from the R2, it will find the entry here and it will reach to the particular destination. And what you can see is every routing table is having its own entry where direct connections are there and where the next router is interfaced. When your direct connection is there, that means that host or that network is directly connected to the router. If not, through which router it is reaching to the destination. That entry is there. So, and how optimally use this routing table, how routing table get updated. Okay, what are the different criteria parameters for this, and how it will keep the track of all these routers. That is very interesting phenomena, because if you look at the network size, it is very big, and from that, how the every router will find out the path and send the or forward the packet to the particular port so that it will reach the destination within number of hops which are less than TTL. Okay, which are less than TTL. Otherwise, it will move here and there, and afterwards TTL count becomes 0 and it will get dropped. Because if suppose this is the scenario, this will forward the packet here, this will forward the packet here, this will forward the packet, again it will come back. So this particular phenomena is called as looping. Without finding the path, if packet moves here and there, looping takes place, and because of looping, TTL count becomes 0 and packet get dropped. So maximum time you have to avoid this looping. Otherwise problem starts. Okay, so if at all routing table gets corrupted, sometimes looping may take place. We'll see the different examples and scenarios for this that will clear the idea, and it is very interesting further. So delivery of IP datagram, there are two processes. One is called as forwarding, and second is called as routing. So forwarding means how to pass the packet from input interface to the output interface. And routing is how to find the setup for routing table. Okay. So forwarding must be done as fast as possible. Okay. All PCs done in the kernel operating system. Routing is less time critical. So it is the background process. Okay. Now we'll see one by one the concepts. Up to this point clear, so that you can see the diagram, which is clear cut, giving the idea regarding how the IP datagram get processed. Okay, now what you can see is there is an input queue. So it will take the packet up, and here it will take the decision. Okay, if destination address is local, means directly connected, the packet will forward it here, and on the basis of this, whether it is TCP or UDP, it will acquire the packet. It's very simple. That is direct interface. It will find destination address is local, it will send it here, so that it will send it to the upper layer protocol, which are transport layer protocol, TCP or UDP. If not, if it is not local address, IP forwarding is enabled. IP forwarding is enabled. If not enabled, it will discard the packet. Otherwise, it will check the next hop, and for that it is taking help of routing table. Routing table will give support for the next hop. Okay, routing table will give the support for the next hop. So while supporting, there are two parts. One is called as static routing. Another is called as dynamic routing. In the static routing, all the paths are pre-decided. That's why the packet will move that with that particular path only. Dynamic routing is table gets updated on the basis of network scenario, and it will forward the packet on that basis, and then it will send the data. So this is the actual process. If at all local, no need to process, it will take the packet inside. If at all not local address, IP forwarding gets enabled, and depending upon the routing table, it will check what is the next hop, and then it will forward the packet to the next hop. Okay. Now processing of IP datagram. Okay. So main difference is IP forwarding is enabled on the router and disabled on the host. So if datagram is received but it is not for the local system, the datagram will send to the different system. Okay, this is called as forwarding. And if datagram is received but it is not for the local system, and datagram will send to the different system, if at all it is enabled and disabled. So on the router it is enabled, on the host it is disabled. Now this is very important, interesting. When the router receives the IP datagram, what different processes are carried out? Okay. So first it will validate the header. How? First it will validate the header. How? Got the question? When any IP packet, IP datagram received at the router, the first it will validate the header. How? This particular is very important from the MSc point of view. This is the last point which we are going to discuss for MSc, because before MSc, yes, very good, 46 because header validation will carried out because IP header contains header checksum, because that gives the guarantee that header is intact. Otherwise, there may be problem in the addresses, there may be problem in the another part, then that if at all header validation goes wrong, that packet get dropped. Okay, so first part, it will validate the header, and then it will process the options in the header. First, parsing the destination address, and then look in the routing table whether that is need to be forwarded at which particular port. After that, very important, it will decrement the TTL count. It will decrement the TTL count. And here, if TTL count, it receives the packet with TTL count 1. If it receives the packet with TTL count 1, after decrementation, if at all it is not for the same host, it will get dropped. So this happens at the every router. So after processing, first it will decrement the TTL. First it will decrement the TTL. Then it will carry out fragmentation. Then it will carry out the fragmentation. Okay, if necessary, means because router is having the information regarding the MTU, which is prime important for fragmentation. If MTU is allowing this entire packet to transfer in the network, not necessary to fragment the packet. If MTU is less than the packet size, if MTU is less than the packet size, then it is very much essential to carry out the fragmentation. And in the last few lectures, we have already discussed how the fragmentation gets carried out. Actually, slicing of data packet takes place, header gets added. Header gets added. Then it will calculate the checksum. Then it will calculate the checksum, because after fragmentation, this checksum also gets changed. After fragmentation, this checksum also gets changed. Then it will transmit to the next hop. Then it will transmit to the next hop. That this we have not discussed, but if it is ICMP packet, it will send the ICMP packet, means reply back if necessary. Okay, reply backs if necessary. Then which are the field are not at all processed by the router? Which are the fields are not at all processed by the routers? Anybody? Which are the fields remains unchanged after fragmentation also? Or how it will come to know whether it is ICMP packet or not? How IP datagram will come to know, whether router will come to know whether it is ICMP packet or not? Anybody? Because once you understand this, everything becomes very simpler for routing. Because there is a field in the IP datagram called as protocol, not type, protocol. Okay, protocol gives the information whether it is ICMP packet or not. Okay. Then which are the fields are not changing? After fragmentation also. Tell me one or two. Source ID, destination ID. Oh. 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 it is interesting. The field which is not changing is header length. The field which is not changing is header length. Okay, because header length will remain same for all the IP headers or for all the IP datagrams which are forwarded. Okay, we'll see that what exactly the source and destination IDs are significant, but here this field from the upper part of the IP header, which is not at all changing, because if at all gets fragmented, he need to calculate the checksum again, TTL count bit get changed, okay, then total length get changed, but header length remains same. Header length remains same. Now we'll see different routing protocols. Okay, different routing protocols which are typically unicast routing protocols. Unicast routing protocols. One is RIP, which is called as Routing Information Protocol. RIP is Routing Information Protocol. Then open source shortest path, and this border gateway protocol. This is border gateway protocol. These are all unicast protocol. We'll see one by one what exactly this. But most of the time RIP is widely used in many of the cases. That's why we're discussing this. So there are two networks. One is called as autonomous network, which is completely under control of, or there is administrator for this network, so that he is having full flexibility to implement this. Okay, this is called as intra-domain routing. Intra-domain routing, and when such all autonomous networks are connected, which is typically called as inter-domain routing, means if you are within the organization, Walchand College of Engineering Sangli, which is under control, is called as autonomous network, where administrator is setting all the rules and other part. So it is fully controlled network. But once the packet is going outside, we call this as it will get connected to another autonomous network. So there are two routings. One is called as intra-domain routing, which is within the network. Once packet is going outside, we call it as a inter-domain routing, from one domain to the other domain, from one domain to the other domain. So this is autonomous system, so that all the routers get connected, so packet get forwarded like this, and it will reaching to the destination. So autonomous system 1, 2, 3, 4 are connected. Sorry. Then intra-domain routing protocols are RIP, which is distance vector protocol, OSPF, which is link state protocol. Link state protocol. Distance vector is typically controlling everything within minimum number of hops. So here what we required is graph theory scenario. Okay, when all interconnected networks are there, how optimally it will find the destination within minimum number of hops with the minimum, what we call it as a link weight. On that basis it will work. Link state is again, it will take into account what is the traffic and other scenario, because in the first few lecture what we have discussed is, if at all you want to go to the particular destination, for that matter, now MSc is starting, so if at all you are in the campus, at that time what you are doing is, you are going to the Vishrambagh Ganpati temple, okay, for pray that, oh God, MSc is there and this, that. So for that, what normally you are adopting is, you are going to by 100 feet road and reaching to the temple, because it is the shortest and straight path. But if at all it is Sunday, what happens is, Sunday full market on that particular road. So longer time will take to reach to the destination, so you are adopting the different path. Okay, so this is typically distance vector in link state. Okay, it will take state of link into account. On that basis, it will get forwarded, and the distance vector is completely based on path or distance in terms of hops. Distance in terms of hops. In that case, it will not take complete what we call it as a traffic into account, but it will find its own path. When an intra-domain routing is there, it is path vector, which is border gateway protocol. Because when you are crossing the autonomous system, BGP comes into the picture. So distance vector routing, least cost route is the process. Least cost route is the process with minimum distance. With minimum distance, that we'll see later while solving the example. And it maintains the table to every node. It maintains the table to every node. Based on the table, it will get forwarded. So what we need to discuss is how these tables are, how the table get initialized, then how the other router will come this particular information, when the table gets updated, how it will share and when it will share the table. Okay, and these two are very important and interesting phenomena which are called as 2-node instability and 3-node instability. Okay, 2-node instability and 3-node instability. I think time is lacking, so that's why covering all the points are not possible, but we'll see at least one point in detail, okay, which is typically initialization of routing table. See the figure. So what you can see here is A is directly connected, B is at distance 5, C is at distance 2, D is at distance 3, and E is this 2 and this 4, 6 through C. Because what you can see here is, if I go by this way, it is required 8. If I go by 2 plus 4 plus 3, 9. There are multiple paths to reach to the destination, but how it has come to the conclusion that this is the lowest path, because it may forward the packet to the B and then it will go to the E, so it will take count 8. It may forward packet